I just drove cross country a few months ago in my Tesla to set the full self-driving cannonball record. The first time we were successful. It was 99.4%. I forget the percentage. It was well into the 90s percentage FSD engaged, no hands on wheel. The second and third attempts, we hit light rain and FSD disengaged. I've been in rain of similar severity in a Waymo, and it kept going. So Tesla has work to do, but they can absolutely both solve it. So the next level question for Tesla versus Waymo is, which one of their business models can actually survive and thrive? I think they will both be successful, but if there is a race in self-driving, it's not to deploy a car here or there.
Since this episode was filmed, in January of 2026, Alex Roy, Warren Honor, and Paul Pham set the first fully autonomous zero-intervention cannonball run record from LA to New York in a Model S. In the middle of winter, through extreme cold, snow, ice, slush, and rain, FSD drove 100% of the 3,081 miles of the journey. They made it across the country in 58 hours, 22 minutes, nonstop. Tesla FSD version 14223 is a game changer for personal autonomy. Welcome to the Futurecaster podcast, where we give you a front row seat into the future of business, life, and human potential. Today, we're speaking to Alex Roy, legendary endurance driver, mobility futurist, and boundary pusher at the intersection of man and machine. From setting cross-country speed records to exploring the cultural consequences of autonomous driving, Alex has always lived at the edge of what's next. We explore how AI is already reshaping motorsport today. Then we dive into what's coming, racing beyond Earth. This episode blends the real, the radical, and the road ahead. Hi, Alex Roy.
Hi, Bates. It's great to see you.
I really want to share your story with the audience. It's a fabulous story. Let's start from the very beginning, how you got interested in racing, and take us all the way to today and even into tomorrow, where you're sitting right now at the frontier of AI and the future of motorsport.
Well, thank you. I grew up in a car family. My dad had a car rental company. We would spend summers in Europe for 3 months, rent like a family car. When I turned 16 and had a learner's permit, he let me do all the driving. And so that was an amazing, bit of driver education for an American teen. I think a pivotal moment for me was watching this 9-minute video of French director Claude Lelouch sending a car across Paris, running every red light. I saw it, when I was in high school, when it was an illegal VHS. My dad has hundreds of dollars. I'm like, I'm going to do that someday. And, this is before the internet, so there's no information about how that actually happened. And so, reading car magazines, and I heard about the Cannonball Run. But I grew up in New York City, so it wasn't really car culture, and certainly you couldn't go-karting in New York in the 80s. And so the concept of, endurance driving, I followed like 24 Hours of Le Mans and Dakar and Baja 1000. But as a New Yorker, it just really wasn't it wasn't really an option. But right before my father passed away, he told me that he'd wanted to enter the Cannonball Run race, which was an illegal race across the United States in the 70s, but that he hadn't done it because my mother threatened to leave him because he had two young kids. But so after he passed away, I'm going to go do that. Now, I'd been to a bunch of racing schools and I'd done some track days, but I wasn't really interested in track racing. I was very interested in all the technology that cannonball drivers used in the 70s to get across the United States as fast as possible without getting caught. And, back in 2000, 2001, the technologies were so much better than they were in the 70s, but especially things like MapQuest, which is dead today, what was cutting edge 25 years ago. And so, around that time, I was, a tech investor, an angel investor, and I was, really thinking what if I wrote a business plan for how to break the Cannonball Run record, but I treated it like a startup, like a tech startup. And I did a SWOT analysis, 18,700, police departments, where do I get the, geospatial data on the roads? How much data can I collect about police location? And so treating it like a tech startup combined with a bit of how Le Mans teams, manage 24 hours of racing. And then having been a gamer and obsessed with military simulations, I was like, how do I tie this all together? And so in 2003, entered a car rally called the Gumball 3000, where I met our colleague Nick Connor here. But going into it, I was not interested at all in the parties or the fun aspect. I was interested in it solely to determine how one drives a very long distance at the highest possible speed without getting caught. And the end goal being to break the Cannonball Run record. And so I arrived on the Gumball, 3000 rally dressed like a German police officer. But that was basically just a cover story for what I was actually doing, which was testing all the hardware and software I thought would be necessary to replicate the Cannonball Run races of the 70s. And so my car was, we had a fuel cell, laser jammers, radar detector, gyro stabilized binoculars, everything that the folks had in the 70s, but better. And over the course of 5 years and dozens of car rallies, determined that it was possible to cross the United States or Europe or North Africa and parts of Asia at 150 to 180 miles an hour, dressed like a German police officer and not go to jail. And so my theory was, well, if we could do this in uniform in a fake police car and we remove the uniforms, we are unstoppable. And so a pivotal moment came in 2000, I think it was 5. Google acquired Keyhole at sometime around that period. Keyhole was the Department of Defense satellite system used for military work. And when that was superseded by the next better system and became Google Earth, I'm like, well, this is it. This is the tool I've been using, I've been looking for. And so drove cross country again, used a FLIR thermal camera on the car, recorded the latitude and longitude of every incoming signal that could be police, built a spreadsheet of all those data points, placed them in a data file, exported it to a GPS unit, got 8 more such units, put them all in the car, and went across again. And so having driven that route multiple times and then looked on my desk, one screen was the driving video. The other screen was Google Earth, driver POV, matching speeds and rolling through the terrain as if we were planning a military operation. It was very easy to correlate the latitude, longitude of incoming like radar signals and laser signals to terrain features where a police car could hide. And so culled that list down to create a data set that I was highly confident was accurate to police location and went across again. And over the course of multiple drives, it became apparent that I was correct. And if we added a spotter plane with triple redundant communications to the car and a fleet of scout cars, it would be virtually impossible to be stopped by law enforcement. So that was the beginning of my racing career, but I would call it more of like an ersatz racing career because this was not a form of racing which is legal or even recognized at 17 years ago. But the path from that to today was we went public, we broke the record. I got a book deal and a movie deal. That was my ROI on this ridiculous business plan, and was instantly contacted by people who had participated in the DARPA challenges. In 2005, 6, 7, DARPA put on these events where a variety of university teams had to try to cross through urban environments, desert environments, autonomously. And all these guys who emailed me, having read the Wired magazine article about us, said, you use the same hardware and software we do, except you're doing it for selfish and illegal ends, and yet we're doing it to make driving safer. You should come speak. Went to MIT. I went to the FBI. I went to like pretty much every government and university that was working anything autonomous, and talked about how we did it. Began angel investing. Launched a podcast called the Autonocast about the future of transportation, and spent 10 years investing in the sector. Met everybody in autonomous racing, electric racing, and eventually was recruited by Argo AI, which was a self-driving car company that raised $4 billion. That was Ford VW's self-driving car company, and became an executive there by accident because they had read my book and seen the Cannonball movie. And when that ended, I'm like, this is it. I'm going to spend the rest of my life investing in technologies that move things more efficiently or faster or safer, and maybe even all three. And so today I have a venture capital firm called New Industry Venture Capital, and I invest in everything I've ever used and the next iteration of that.
That I remember coming to see your film at the LA Auto Show. and it was amazing. I have to say thank you for showing that to everyone. It was if you haven't seen it, you must see it. Where can people find it?
It's the movie is called Apex: The Secret Race Across America, and it's on iTunes and Amazon Prime.
One thing that I noticed in the room that night, there were men in blue, there were a lot of police officers, and you were talking about how you got away with all of this stuff. So I'm wondering, in the end, were you pardoned?
I did get some curious letters from the FBI and some other agencies, but the Bureau's interest was primarily uh, in understanding how someone with no background in law enforcement or in the military could operationalize a plan to get a car across the United States at high speed and not get caught. Their goal was to prevent someone who was a bad actor, say transporting weapons, explosives. If such a person knew what I knew and taught themselves the techniques and the technologies that we'd used, how would they be stopped? And so everything that did not go in the book that my attorneys had omitted was shared in several years of kind of private conversation with various law enforcement agencies. And they amazingly are a lot of car guys. And I got a tour of the automotive and technical unit in Quantico, Virginia, where I was one of the speakers. And the stuff they were doing, they all said the same thing. They would love to do the cannonball, and they had technologies and techniques that would make it. They could break my record. This is back in the day.
I'd like to hear from you basically how you think AI is already reshaping motorsport today, from the pit lane to the race strategy room to predictive analytics.
The fundamental misunderstanding and opportunity in applying AI to how cars drive is to understand the box in which almost all development has occurred, and it's a semantic box. Which, in other words, almost every application of technology, even rules-based pre-AI hardware and software, going back to say early traction control and anti-lock braking systems, have a form of primitive intelligence. But everything from there all the way through today and driverless cars like Waymo's, all of it is designed inside a zero-sum box. So the more the technology can do, the less the humans should do. And the end goal of such a way of thinking about technology is the elimination of the human driver altogether. Now, that if safety was the only goal of adding technology to cars, that would be a worthy goal. However, cars are both transportation, but they're also transformation. If cars were just transportation, there would be no reason for anything better or more expensive than a Toyota Prius to exist. And yet Porsche exists and Ferrari exists. The reason sports car brands and car racing exists, certainly up until now and for the foreseeable future, is to demonstrate how much can we amplify human skill. Because humans need catharsis and agency, and they need and want to buy things, clothes, tools, cars, that both reflect who they believe themselves to be, but also amplify the best they think they can be. And that is reflected in motorsport and Formula One. And so all automotive development with AI thrown into it, unfortunately, is at odds with that. Because the better cars get at driving, the less necessity there is for a driver. And so that is a tragedy, and that it's a choice. It's like a cultural and civilizational choice. And it's the difference between an Iron Man suit and the Wall-E chair. Like, which would you like to have? Optimally, you have a choice. If I want to do stuff in my Iron Man suit, great. But when I want to relax, I want a Wall-E chair. Unfortunately, every car maker on earth, with one exception, is building Wall-E chairs. That's what they see the future of cars to be, the cars we buy. So that's really unfortunate, because the human autonomy, which is just a fancy word for freedom, and agency, the amplificatory power of technology, lies in building an Iron Man suit with wheels. We have not yet seen that in the consumer market or even on the horizon. So that's consumer vehicles. We have seen in racing the application of technologies to make the cars go faster without eliminating the input of the human driver. And uh, have you seen the movie Senna? It's really a movie about the man, the best driver on earth facing forces beyond his control, and specifically a rival team in the movie. Senna he's just pure skill, like analog car, no tech. It's just human amplified by car. And McLaren puts in an active suspension system. And if I recall correctly, based on the vehicle's location around the track, the suspension would preemptively reposition itself such that the car's physics are optimized for every corner. And so a driver of lesser skill in that car could defeat a driver of greater skill in a pure analog car. Senna and all the great drivers of analog cars, they are always thinking, how can I position myself not just for maximum speed into, out of this turn, but what do I have to do entering the turn to position the car and load the suspension correctly? So, complaints were filed after several races, and that active suspension system was then banned. So we've seen, in the recent decades, a variety of technologies added to Formula One cars, and also in Le Mans and other racing series, which do amplify the abilities of drivers. But they're often limited to a single team. You rarely see a spec series which has everybody benefiting from the same tech. And this tech is, in Formula One, it's so wildly expensive to develop it, to deploy on a single car. It's just not feasible. And it's really not feasible for anyone but the biggest teams. So that is fascinating to me, because in a perfect world, the pinnacle of motorsport, everyone would have access to the cutting edge technology such that driver skill becomes the thing that matters again. And yet that's not possible because of the R&D budgets required to develop these technologies. That being said, there was a fascinating article, I think it was in Car or Automobile magazine in the early 90s. Gordon Murray, the designer of the McLaren F1, and 2 or 3 other like world-class like F1 racing engineers were asked, what will race cars look like in 50 years? And each of them had a completely different vision, but they were all really ambitious. One of them was resembled like an eagle about to take off, like wings like half spread, and it had like 20 wheels, and it looked like a train with wings that were spreading. And the designer suggested that the driver would only have one input. It was a button, one button, and that the vehicle would drive itself around the course in the optimal path, and the button was aggressive pass, because they felt that only a human driver would be able to push beyond what physics and the map could tell the car what to do. It would still need to be some final human in the loop. The other vehicles looked different, but basically had the same input set, which is a button. Maybe there was left, right, like rocker switch. And so they all defaulted to letting the car do most of the critical path planning, and left only like a final, risk amplification choice to the human driver, who remained on board to suffer the consequences of a mistake, which is a very essential part of human driving. There have to be consequences to decisions, or you might as well stay home and play a video game. So that McLaren with the suspension in the Senna movie, and that article in Automobile, to me, are like the 2 most important pieces of content one can digest to understand what the future of racing could be. And so it is essential that we pick Iron Man as the default setting for teaching kids how the world works, such that they can improve themselves and the world, as opposed to starting off from a Wall-E setting, which is everything will be done for you, and to do nothing is a viable choice, because that lesson is it's the end of progress in any area as we know it. This is what I hope the future of all driving and racing will be a search for better versions of an Iron Man suit. And unbelievably, the best example of AI applied to a sport isn't in the real world at all. There's a movie called Real Steel. Hugh Jackman with robot boxing. This is the third most important piece of content for anyone thinking about putting AI into any type of automated machine or device of any kind. In the movie, in the future, boxing is illegal, human boxing. It's too dangerous, it's cruel. And so robots box. But the robots are the creation of a team with a singular charismatic, team leader. And so the robot designs and fighting styles reflect that team leader, which solves a problem of whom should we root for? No one really roots for a robot, but you can root for the robot if you like the guy who built it. So in the movie, the robots are they can fight fully autonomously. However, the hero robot is smaller and weaker than the antagonist. And Hugh Jackman is a retired former boxer. And as he takes his robot with his son through a series of matches, um, they face harder opponents. And at the end of the film, they face an opponent they cannot defeat with the pre-programmed fighting algorithms. And so Hugh Jackman puts on a pair of gloves, haptic gloves, and he allows his robot to proceed using its built-in defense algorithms to block. But when it comes time to attack, he inputs the attack in the haptic gloves, and because he's both better than his own robot's offense and behaves unpredictably and against what the opposing robot predicts their bot will do, they win. And so this X factor of human input interfacing harmoniously with an automated system is the future of racing if we want racing to survive as we know it, if we want humans to be in the loop. We have not yet seen anything like that in cars. And sadly, the companies that should understand this best, Porsche, Ferrari, all the F1 teams, to the best of my knowledge, unless they have a secret program somewhere, none of them are thinking this way. When you go to a racing school today, even like a top tier, an F1 school, you go there, they're recording telemetry in the car, they're recording video. You get back to the pit, you get back to the classroom, you look at a map, they show you your sector times. But the real application of AI in racing, like the dream, would be a real-time, in-car driving instruction system. You're driving, the vehicle would predict you're about to make a mistake. It would warn you such that you could preempt it or mitigate it. And if you failed to do so, it would take action to prevent a crash. And as your skills improve, the boundaries of the vehicle's performance envelope would expand or contract based on your inputs. And over time, would allow you to take almost unlimited action with unlimited inputs if you were demonstrably better than the simulation and prediction models of the vehicle itself. We're a long way from that.
That allows different drivers with different skill sets to compete against each other.
I do think that as a training tool, that would be optimal. In a perfect world, an AI-driven real-time driving education system would exist in all passenger cars and in racing schools. When you got to the actual track, it would invert. So the vehicle might have a far outer boundary that would disallow a crash. But inside that boundary, anything goes. Because ultimately, like, what is the perfect sports car or race car? Perfect sports car is a Porsche 911 that will you do whatever you want, but won't let you hit anything. And a race car is exactly the same way. AI has to improve dramatically. It has to pretty much get to fully driverless operation before you can work your way back and build a product that would accommodate or allow for what I'm describing. You really can't build this system until a driverless vehicle can lap a track with a record time. And once it can, then the envelope of the vehicle having done so is the context inside which you'd build a user interface for humans to race inside that envelope.
So what I'm hearing you say is that the best form of intelligence for racing might be when it helps us to become more superhuman. And it enhances our own ability, and it's our intelligence partner in the vehicle during the race, but also gathering all that data that takes so long to analyze in the past, but now it's in an instant, it's real time.
The word I try to use is augmented, because right now you have driverless cars and cars with driving assistance. Driving assistance is by design and semantically a zero sum game, but augmentation is not. So I hope that people will start building systems that augment and amplify human skill, and then the words will swap. There is one company today, and it's ironic because it's Toyota, that is trying to build an augmented driving system. They have a system called Guardian, which does function as I described, but is many years away from deployment in the form I'm describing. Toyota also has acquired a number of companies, including mapping companies, so they can build high definition maps that would allow for driverless operation. Ultimately, high definition maps of the world will be available, which will allow any car to accurately predict and avoid crashes the same way an F1 team will have LiDAR mapped every track and know down to like the millimeter where there's an imperfection and optimize their racing line to avoid it. So it's the quality of data and is more important than quantity of data.
On your race years ago, you had a plane, right,
Yes.
with you that gave you
Yes.
insights and foresights and everything. So could drones become a cheaper version of that plane for racers? And have they already?
I'm so glad you asked. I have, in 2012, I asked my lawyer, I had him write a brief about the legality of flying a drone around the perimeter of Manhattan Island. I had set the lap of Manhattan record at that point, inspired by Rendezvous in Paris. And I wanted to do it again with a drone, one flying ahead to recon the route and one flying behind to shoot video. And legally, that was a very bad idea, but functionally could have worked if the drones at the time had collision avoidance software on board, which they did not. So today, if one wanted to replace my spotter plane going cross country, you would need a military grade drone, and you need more than one because they're range limited. So my spotter plane, we left New York at night, got to St. Louis at dawn, and you drive to Albuquerque, it's dusk. So the spotter plane started in St. Louis and flew to Albuquerque and had to refuel, I think, once or twice. And that was a King Air, a twin engine pressurized aircraft for like 6 or 8 people. Nothing smaller than that could have even done the speeds we required. So drones that could fly 100, call it 120 to 160 miles an hour over distance don't exist in the civilian market. Not yet. And the military has a wide variety of drones. So you need several in a row. The missing piece is a software platform that could integrate the data from the drones with radar and laser data, plus weather data, plus traffic data, and predict choke points in advance over time, and then integrate with real-time data coming off the drone and check it against like an HD map to see if like a new pothole had emerged. And then you could plan around that. These platforms exist in the military, like intelligence and like real-time like data aggregation and processing, and then suggested decision making, these things. I mean, Palantir does things like this, but there's nothing in the consumer market like that yet.
I'm going to pass it to Nick now.
Yeah, all right. I wanted to just go back to sort of man and machine racing. So, I know you're saying like consequences of mistake. That's kind of what everyone's going to pay for. I think that also the human story is like a really big deal.
I mean, I believe you're correct, and I hope that investors and companies see it, because if they don't, we're going to get more robo race events, and what is possible in human-centered AI-supported racing will be delayed 20 years if somebody loses $1 billion building a really stupid tech-focused version. But yeah, I completely agree with you. I could see that show in my mind already. 10 years from now, 20 years from now, where some kid has got a crazy theory about how to build a racing AI, and it's make or break, change his life. And if his car wins, there's like a $10 million prize from a fund to fund him to build dual use drones for military and civilian use. Like, that's a great human interest story. And, the less human input, the less interested I am in watching.
Exactly.
It's just the way it is. I mean, in its purest form, Formula One is interesting because you have both a technology race and a human race at the same time. And the winning team is the one that nails both.
Exactly.
They miss one, they're dead.
Yeah, totally. And if you think like there's, we're talking like the pinnacle of racing Formula One. Okay. But there's so many racing formats that we love, like like the Baja 500 and, where sort of the equipment is wildly substandard for what you're doing. Or, or exactly. Or look, even, when we did a bunch of gumballs, right? And it was the adventure of it and sort of overcoming adversity, not like having the pinnacle of anything.
It's inevitable that a variety of technologies, hardware and software, will proliferate at all levels of motorsport. But I think that they will be in the same way that like streaming music has, increased the amount of music. I don't know if it's increased how much music is listened to, but it's certainly increased the variety of music any one person can listen to, because they're no longer boundaried by having to buy the album. A basic sub gets you everything. So, but the corollary is that sales of vinyl records have gone up. And that is, I believe, a cultural reaction in pursuit of authenticity and ritual, cooking a meal for yourself or for people you love. And so ritual matters. The ritual of putting on a record is very clearly something from which people derive value. And so I believe that as technology, I don't want to say invades, say technology propagates into car racing, and every subset of it, supply chain, sourcing, logistics, support, everything, recruiting, everything, there will be a parallel rise in interest in period correct ritual motorsport. So if I were to organize a Cannonball Run today, knowing that it is virtually impossible at current levels of technology, entire technology, to break the current Cannonball record, I would organize a period correct race of vehicles from 1979. The maps, the parts, everything 79, no phones, nothing. The only exception would be a paper map that is up to date with the roads, but nothing will be allowed post 79 except tires and a paper map. It's why people like us did the Gumball 3000, I think, because we're trying to get closer to something which no longer existed, cross-country racing. I think that vintage racing, period correct, with consequences in old, hyper-expensive vehicles is going to come back in a big way. I think it's a mark of honor to have raced and survived some of those races in the same way that people want to climb Mount Everest. There's no automation can replace climbing Mount Everest or going to the bottom of the ocean, because the consequences are there. And the elimination of those consequences is the elimination of what it means to be fundamentally human.
And I just don't see that sort of wanting to go away. Let's fast forward, you say like 20 or 30 years. I think this stuff's coming quicker, like much, much quicker. Some short period of time, like every car is going to have like the autonomous capability. So let me ask you about like Tesla versus Waymo, because I know you know a lot about this. Waymo, it's sort of, video, but it's also using LiDAR and radar and other technologies. Sort of Tesla they think they can crack it just with intelligence and video.
I ride Waymos almost every day, but I also own a Tesla, a brand new Tesla, and I love it. Tesla will be able to deploy vehicles driverlessly with camera alone. I'm convinced of it. However, there's a term in autonomous vehicle development called an ODD, which just means operational design domain. Waymo skeptics will say, oh, Waymo's geofence is small. Teslas operate anywhere. These are meaningless words because an operational design domain, which is how the engineers discuss the vehicles, comprises area of operation, the weather in which it can operate, shadows, extraneous events, adherence of, pedestrians to local law, adherence of local other vehicles to law. So you go to Singapore, your prediction of behaviors of pedestrians and traffic is very easy. But if you go to, Calcutta or Lower Manhattan, it's very difficult to predict. So the real question is, what is the perceived level of safety of a Tesla before people be prepared to ride driverlessly? The second question for Tesla will be, at what point, what are the acceptable limitations for a consumer for what that Tesla can do driverlessly? To be specific, a Waymo today can operate in a pretty wide range of weather, not heavy snow, but most other weather. And it can operate in, simple to moderate complexity areas. And it can do something Teslas cannot, which is do pick up and drop at airport curbside in Phoenix, where I live. So a Tesla, in order for it to be able to compete directly with Waymo, would have to be able to do all the same things. And so with camera alone, it is more difficult to perceive and do path planning and prediction with fewer sensors. I mean, you just can't see as far as well. You could still deploy, but the speed at which the vehicle could deploy in marginal weather is going to have to be lower than a Waymo, which will have more sensors and more redundancy for perception. For example, I just drove cross country a few months ago in my Tesla to set the full self-driving Cannonball record. And the first time we were successful. It was 99, I forget the percentage. It was well into the 90s percentage FSD engaged, no hands on wheel. The second and third attempts, we hit light rain and FSD disengaged. I've been in rain of similar severity in a Waymo, and it kept going. So Tesla has work to do, but they can absolutely both solve it. So then the next level question for Tesla versus Waymo is, which one of their business models can actually survive and thrive? I think they will both be successful, but if there is a race in self-driving, it's not to deploy a car here or there. Waymo needs to move past, wholly owned fleet robotaxis, fully verticalized in a handful of cities. For them to do that, they need to take the sensor hardware, which is large and many, and reduce the form factor of the hardware such that it is conformal and invisible and can fit on pre-existing passenger car designs that are beautiful. Until then, Waymo doesn't have that business is closed to them. Luminar, a LiDAR company, built a system, I think it's called a Halo. It's a little LiDAR that goes in the top of the center of the windshield of the Volvo XC90, and I think one of the Polestar models. It's as beautiful as you can make a sensor look that still changes the profile of the car. So Tesla's already solved this. The cameras are built into the car, they're invisible. But Tesla has to get their perceived safety to the level of Waymo and deployment before Waymo miniaturizes their hardware form factor. That's the race. Because once Waymo gets there and they can license the hardware and software to any OEM that wants it, then OEMs can start selling cars that are equivalent to Tesla capability, and then Tesla's just another car company. The wild card is that there are at least 2 or 3 other companies that are trying to build, camera first, ultra lightweight, end-to-end neural net AI that could replicate what Tesla's doing. That could also, with very, small format cameras, Mobileye out of Israel and Wave out of the UK. If one or both those companies can solve autonomous driving, and get their stuff licensed to an OEM before Waymo does, it becomes very dangerous for Waymo. They still have a business. They have a fleet-owned, robotaxi business, but they would not have a time advantage. Their only advantage in it for any of these companies is time. Long term, there is no technical advantage. Like the electricity companies and the aviation companies, everyone will solve this eventually. Whoever solves it first will have some period to exploit that advantage and try to get exclusive, partnerships.
Like if 10 years ago you were to parachute like AI people into today, they'd probably go like, yep, you've got like early AGI. Okay. Um, you know, at some point we can accept that like that's gonna come. I mean, we're probably like sort of 12 months away from, an AI mathematician being better than any human mathematician, for example, right? Maybe like 18 months away from an AI coder being better than a human coder. So like super intelligence, it's on the horizon. It's pretty likely. And I don't think most people get their head around what that really means. I mean, super intelligence means it's an AI that can do everything better than a human can, right? So I'm going to sort of bring that back to Tesla Waymo. Like when that happens, the benefit of hardware versus intelligence disappears, right? So, obviously none of us know what's going to happen, but, the intelligence to see in dark, difficult situations, interpret like different movements, all that kind of stuff, right? So, I mean, whether it's Tesla or Waymo or somebody else that wins, there's this future where nobody's driving a car anymore.
Is that a declarative statement or a question?
I think we're going to move forward to some future point, which is going to be where an awful lot of people don't know how to drive.
I agree with you. But let's put some like timelines on that. So without question, there is some end state, like the automotive singularity, where the last person who's ever driven a car decides just not driving anymore, and then the last person is driven and it's over. That day will come. There is only one city in America where you can, maybe two, where you can live without having to own a car, New York City. And maybe Miami Beach and like maybe subsets of some other cities. But New York's the one because it's got the best transit system and no one else comes close in the US. In Europe, in almost every major city, you may never need to own a car. Why would you? What's the point? So it doesn't matter. But let's imagine autonomous vehicles work today, perfectly today, and were affordable today. What would happen is the average car is owned for, I think, 11 years. So unless they were cheaper, dramatically cheaper and subsidized to replace your personally owned human-driven vehicle, that human-driven vehicle you'll have it till the end of your lease or, the end of your financing. And so either 3 years at the short side or 7 years for the rest of the folks. That car is still going to be on the road, sold used cheaply to somebody for another, basically until it's 11 years old, maybe 15. That's assuming autonomy was available and worked today. So add 10 years to a timeline for the beginning of a ramp to ubiquity. Now, we don't have autonomy today. And what I mean autonomy, I mean a vehicle that can drive almost anywhere a human would need to drive in most conditions. Such a vehicle will not exist for, I think, 7 to 10 years. So, Tesla, what they're doing is not magic. An end-to-end neural net can grow and learn. But for it to be not just good enough to drive, but perceived to be safer than me is a much longer term problem than actually getting the tech to work. People have to believe it works. That requires often growing up with it. So my daughter's 7. She believes that a Waymo and a Tesla is awesome. And she already believes they're better than me. And she's like, Dad, why are you in the seat of the Tesla? Like, isn't it just like a Waymo? I'm like, not quite yet. So by the time she's 15 or 20, she is already, for her, it's autonomous vehicles are context and they're a given. And so that's 11 to 14 years from now, assuming that the vehicles can work anywhere. Because until they can work anywhere or almost anywhere, the future is going to be dual mode vehicles. So, and this is what I believe is going to be the next 20 to 30 years of cars. There will be almost every major urban center in America and in the first world will be high definition mapped. And if it's not HD mapped, it'll be mapped over and over by like low res cameras like Teslas have. And this, consistent 24/7 mapping will make it possible for driverless operation in every major city in 4 seasons in the first world. But outside of the cities, it'll be a mixed bag. And in order to sell a car to somebody who wants to be able to go anywhere, there'll be dual mode. So this is the car I foresee it will be available in, 7 years. It's a car that can be driverless inside areas where insurance companies will insure it. And outside those areas, you have to drive it. But the driver assistance will become augmented systems. And so cars will have steering wheels. You can drive it anywhere you want. If you hit a boundary where driverless operation is possible, you'll be able to choose. Dual mode vehicles are going to be everything in this country. Your prediction about autonomous ubiquity is an absolute certainty much sooner in countries like China, Singapore, Japan, parts of Europe. And it depends on the verticalization and like political philosophy guiding that country.
So, Kim, you're the futurist. So with everything that we've discussed, so both the future of motor racing and the future of autonomous vehicles and our experiences, what are you seeing 20 years hence?
One of the things that I do believe in, I think 20 years out, is that we're going to have suborbital racing once that technology is like cheap enough and affordable. I also think the meaning of rider drivers going to stay. And I have this vision of the future where riding and track also become entertainment and physical performance. So I will give you a scenario of the future with a character. Xanthi loves to hit the O-ring. It's a global entertainment membership track club. She subscribes to gaming, shows, and film simulations and chooses the era she plays in. She physically travels around the track on a hydrogen fuel O-mobile. Imagine that the O-mobile looks like a motorcycle, but like a donut with like a big O. And her temperature optimized Tesla suit lets her physically feel the thrill of all her senses. The O-mobile doubles as a personal gym as it helps to burn 1,000 calories per hour via vibrations and electric pulses. She subscribes to licensed holographic characters created by what I'm calling Zollywood Studios in the future. They move from simulation to simulation. She can delete or add new characters to her story worlds. Holographic scenery fills the old track. She uses holographic lasers and weapons to attack her enemies. Xanthi likes to choose a different ending every time she visits this world. So I can imagine that we're going to have our personal mobility racing devices in the future, and it's going to become also human performance and entertainment as well, not just automotive racing in the future.
All gaming, simulation, everything you're talking about, the racing on the O device, Kim, you're talking about, I want all of that. But if the consequences aren't actually physical injury or death, then the consequences have to be 1 to 24 hours you can't play. You have to watch everyone else.
Alex, thanks for coming on the show today. Adore you, and just brilliant thinking as usual.
Thanks for having me. I love you both. Wait, no, I forgot to tell you. You see that picture over my shoulder right there? That's me and my daughter and my Morgan three-wheeler risking our lives for the consequences that make life great. Ciao.
If you're enjoying the show and appreciate what we do, the simplest way you can support us is by hitting the subscribe button and sharing this episode with others. And by doing this, our commitment to you is we'll do our very best to make each and every episode better than the last. See you in the future.